Hi everybody, so here is a short video to show you how to use my new software Wing Hot Wire, which is a software to design wings which will be cut into a foam core. The first thing you will have to do is to make the drawing of the profiles on a DXF file. So here I do use Gcode, which is a free CAD software. The profile are directly input into the layer 0 in black, while the cutouts that will go through the wing are put on two other layers, layer 1 and layer 2. Layer 1 will be attached to the entrado when you cut the cutout, while the layer 2, which is in red, will be attached by the extrado from the top. This DXF is a polyline. You can see it here. The polyline is important because my software doesn't know how to read spline and so on. You can use Lightburn, you can use SolidWorks, it works as well. When you have done this drawing, you can go to the YOY software, import the root profile, import the tip profile, and tune the geometry of the wing. That is, you have to decide the length of the wing. So the length is reflected here on the 3D view, and you can change also the back sweep of the tip compared to the root. You can change the dihedral angle, and you don't have to modify the chords of the root and of the tip because they are extracted from the DXF, as well as the angle from the tip to the root, if any. When I cut this wing, usually I have to I want to start from this side, from the trailing edge. So there is a possibility to flip the profiles and the 3D view follow, so that now the origin will be there and we can cut from the entrado, make the turn and go back. When cutting a wing, you will have a hot wire running here on the profile and melting the foam. There is a curve that is the circle that will be eaten into the foam that you can change. Here it is at 0.5 millimeter. I will put it to 2 millimeters, and as you can see, the profile expands because the wing, the wire will be there and will eat into the foam, while the wire will be inside the cutout and eat there. So the cutout shrinks. Zero. The wire length is also very important because it defines the geometry of your CNC. The motor will be here and there, and you have to define the temperature, but also the feed rate. You can export the Gcode, and when doing this, you have access to a simulation of the cutouts. So here are the paths. Here is the left motor, the right is there. You can move the wire and look at the simulation of the cut here to check that everything is okay. If you want, you can play also, and it will run the Gcode in a simulation way, and you can add the cutouts. And so here it is this mode that I love the more, which is the full path. So as you can see, the wire will enter on the top. It will perform the cutout here, hop, fully synchronized, hop, and etc. etc. Hop, hop. So this is the mode where the core will be cut together with the cutout in a single pass. If you want, you can make only the top skin and the cutout, export the file, and as you can see now, you have only the top skin in the first pass, and then it will go back. It will be fast, yeah, and make cutouts in the second pass. You can do the same for the. You can flip the wing and cut the bottom part. You can make the bottom skin alone after having done the cutout if they are on the entrador. So no cutout here, and export the Gcode. And this will make the final cut, that is cut the bottom of the wing and go back. When this is done, you have access to another program, which is the Gcode streamer. So this streamer will act with the Fluency controller board. So here is only the computer, the motors are not there, but it works, trust me. You can scan, it will automatically discover the port, you can connect, and now the board is displaying his welcome screen and connecting to internet and so on. When this is done, you can import Gcode. So this is the last one that I have generated. I will rather open something more complex, that is this one, which is full with the cutouts. Yeah. So this is displaying something which is interesting. My software is adding some headers into the Gcode from where are extracted the dimensions of the block of the stock, the position of the motors, the wire length, and some other parameters such as margins, top and bottom, and left and right. When you are here, you can move the wire, change the speed rate for jogging, and move either one motor or the other, or even both, so that you will go to the origin. Suppose that now the wire is touching the block, then you can zero the origin of the machine and you are good to go. It means that you can easily run the Gcode. I will do it. Beware that on this simulation, on this Gcode, the feed rate is very low, that is 100. It's a real cut, so it will not go very fast here. This segment from here to here is a single motion, so I cannot change the feed rate inside this motion. I can do it, but it will be taken into account when the wire will arrive here. So we have to be patient. On the other hand, I can change also in real time the hot wire temperature. So I will put it to 500. And it will be taken into account immediately. What you could do also is to pause the motion. Here it's paused. It's not really a good idea because the foam will still melt here because the wire is already into the foam, but you can resume and the motion will recover. If you push the button on a long click, then the motion will be killed. The Fluency will probably go into alarm mode, and you will have to click again on the stop button to clear the alarm. So a single button will pause, resume, kill, and clear the alarms. So now we are into the motion, into the core, and you can see that the feed rate of 1000 is effectively taken into account. The cutouts are fully synchronized. Second one, we go to the leading edge, we go back here, there is another cutout there, another one here, and the motion will finish here and then you can see that the speed is fully synchronized compared to this edge and this one. And here the motion will do exactly the contrary. It will be slow on this side and fast on this one. And finally the wire will go top and stop the heater. So you have a system which is totally usable to cut any Gcode file. Something which is also interesting is that if I reset here, for example, and I want to cut a wing with a dihedral angle, that is to connect two parts of the wing, I would like to cut not vertically but with an angle which is a dihedral angle. Let's say I put 45 degrees, which is quite a lot, and I move into a vertical motion. You will see the wire going to the right. So here. So this is very useful. You can go put the wire under the wing, under the block, and then cut it in diagonal. Going back. And of course, to do this, because I was into the phone, I should have switched on the heater, which I can do here easily. If you want to cut the symmetrical wing, you don't have to go again into the CAD program. You just import a file and swap the motors, and look at what will be done. I will try to open the same. So this one and the two profiles will be swapped, so that if I cut this wing, it will make the right wing from this left Gcode file. You can go also to 0 using this button. Hop. And that is basically all what I wanted to show you. You have also this console where you can enter any Gcode you want. For instance, G1 X50 with a feed of 1000. No, sorry, I've put X and you send it, and only this side of the motor is moving because it is the next motion. You can go to 0 again, and so on. So this software, as well as the YOY one, are totally free and are accessible into my Hackaday project, which is linked into the description of this video. Try it, tell me if it works or not, tell me if you want some additional features. I will do my best. So thank you and goodbye.